Okay, the last thing we're going to do with stoichiometry problems is the idea of percent yield. Basically, when you set up an equation and you go through all the calculations to figure out how much you're going to produce, that's under ideal perfect conditions. But in reality, you usually end up with a little bit less. Maybe, a little bit of air, maybe a little bit is spilled, maybe a little bit still stuck to the container, but there's always a little bit less. And so you want to figure out how much you actually produce in terms of the reality as opposed to what, shall we say, the math says you're supposed to do. Now, basically, percent yield equals the amount recovered divided by the amount expected, and then times 100% to, of course, make it a percent. So let us look at a percent yield problem. Now, in this particular case, we don't have to worry about limiting like we did in the last set of notes, because all I've got is 46 grams of sodium and I have all the oxygen I want, so I'm only going to be using the 46 grams. So let's go ahead and label this 46 grams there, and that's what I want to find out. How much Na2O2 am I going to produce? So first we're going to go to moles. So 46 grams times 1 mole over 23 grams equals 2 moles of sodium. So that's how much sodium I started with. Remember, our coefficients always represent moles. Okay, now step 2, we're going to do our mole ratio. So we're going to take our 2 moles times, now in this case we want the question mark always goes on top, that's the Na2O2, the sodium oxide, so the mole ratio would be 1 over 2. The 1 is from what's in front of the Na2O2 and the 2 is from what's in front of the Na. And so that tells us that 1 mole of Na2O2 is produced. And again, it does help to do some labeling just so you can keep everything straight. Alright, so that's how much is produced in moles. I want to now do step 3. In this case, go to grams. So my 1 mole times for Na2O2, it's 78 grams per 1 mole. And since I have 1 mole of this, of course, I produced 78 grams of Na2O2. Okay, so there's my 3 steps of stoichiometry. And then really what's going to happen now is I do the percent yield step. So note that it comes after the stoichiometry steps we have done in the past. And again, our percent yield is the amount recovered. Well, we only recovered 70. We didn't actually get all 78. We're going to divide by the 78 times 100, and that'll give us our percent yield. So, percent yield, which again is the amount recovered divided by the amount expected. This here, that was the expected amount. Okay, that's what the math says we should have gotten. Okay, but we only got 70. Okay, and again, times the 100% part. So we've got 70 grams over 78 grams times the 100, and our answer is 89.7%. So that is the percent yield. Almost 90%, which would be pretty good, actually. Now, we're going to kind of come at this problem from a different direction. Let's suppose that, we had done this particular procedure a number of times, and we consistently came out with a percent yield of 75%. So, how many grams of Na2O2 will we actually recover? So I can kind of go in the opposite direction. I can take the 78 grams that I was supposed to times, I want 75%, so I have to write it as a decimal, and I come out with 58.5 grams of Na2O2 recovered. So if I happen to know what the percent yield was, I could work out how much I should actually expect to get. In other words, in reality, it's always going to be a little bit less than a perfect situation. All right, let's look at another case. In this particular case, notice that I have two amounts. So here I have 58.2 grams, and here I have 12.8 grams. And really, this is going to be my question mark, because that's what I want to find out, the percent yield. Now, since I've got both amounts here, I do not actually know which one is the limiting off the top of my head. I'm going to have to go to moles first, just like we did with limiting reagents. And then once I have the limiting one, then I can go find out how much I actually expected to recover in the first place. So we need to go to our moles. So first off, go to moles for both of them. So the 58.2 grams times 1 mole over 97 grams gives me 0.6 moles of the ZNS. And then 12.8 grams times 1 mole over, let's see, 32 grams gives me 0.4 moles of O2. So I have 0.6 for this one, and I have 0.4 for that one. Okay, then we got to use our mole ratio to figure out which one is limiting. Like I did in all the other problems, I'm going to start with the first one and then use, in this case, 3 to 2 to find out how much O2 I would need. So 0.6 moles times 3 over 2. Again, the 3 is here, the 2 is there. That tells me that let's see, 0.6 times 3 divided by 2. That says 0.9 moles of O2 needed. Of course, I only have 0.4, so not enough, which means the O2 is limiting. So now that I know that, it's the O2 that I'm going to use to find out my ZnO, my zinc oxide. So I'm going to take the 0.4 moles. Let's see, we're going to go to grams. So we're going to take the 0.4 moles of the O2 times, now the ratio here is 2 to 3, again question mark on top, so 2 to 3, which gives me 0.267 moles of zinc oxide produced, and then times, because we want to be in grams, so for the zinc oxide, that's let's see, 81 grams per mole. So I'm just going to go ahead and string them together here, 81 grams per 1 mole, which will equal 21.6 grams of ZnO expected. And so we've gone through our stoichiometry. This is how much we should have expected, 21.6 grams. However, we only produced 16.2, so the percent yield, which is the amount recovered divided by the amount expected times the 100 to make it a percent. So we're going to have 16.2 grams over the 21.6 grams times the 100, and we get 75% as the percent yield. All right. One last example, and this one's a little different because note that these are all gases. I have 30 liters of the C4H10. I have 200 liters of the O2. I want to produce 96 liters of the CO2, or that's what I actually ended up with. So, you know, you might think, well, wait, is it already done? No, this is the actual recovered part. Just doesn't use the word recovered. That's what was recovered. We need to find out how much was expected. But because everything is in liters, I can actually skip a couple of steps, because to go from liters to moles, I would divide by 22.4, and then to go from moles back to liters, I would multiply by 22.4. No use to do all those stuff. It's kind of like the volume problems. All I need is the mole ratio. So let's first see which one is limiting, because I have 30 liters here, and I have 200 liters there. And this is what I need to find out, the CO2, so that I can compare it to that 96 liters. So if I take the 30 liters times 13 over 2, because that's the ratio in the problem, for every 13 here, I only need 2 there. So if I do that, it ends up 195 liters of O2 needed. Okay, I have enough because I have 200. So the one that I have enough means the other one, the C4H10, is limiting. And so now that I know that that's limiting, I can do a second volume problem to compare the C4H10 with the CO2. And so I take my 30 liters. Now my mole ratio is 8/2. Again, the question mark on top. So 8/2, which is basically 4, which means 120 liters of CO2 expected. Again, the idea is if I'm using all 30 liters of C4H10, I should produce 120 liters of CO2 if basically everything went perfect. Unfortunately, I only produced 96 liters. So, in this case, my percent yield is going to be the 96 liters over the 120 that was expected, and then times 100%. And that comes out to an 80% yield. So not quite as much work if everything is in liters. Likewise, if the problem had been moles to moles to moles, and I didn't have to go from grams or any kind of mixed units, problem ends up being pretty quick, even to check which one's limiting, because they were both in liters. I could do kind of a volume type problem. For 30 liters to be used, I needed 195. I got 200. I have enough. Therefore, the 30 liters is the limiting part. Then use that to figure out how much CO2 is expected. Again, it's a volume problem, so all I need is the mole ratio. And then how much I actually recovered versus how much I expected to, times 100, and I have my 80% yield. So, percent yield problems.